Hi there, this is the, oopsie, move it down so you can see it. We're still looking at trig ratios. And again, one of the problems I find with students is that they look at the question and go, that's all fine and dandy, but I have no idea which of those trig ratios to use. Or they'll say, I'm gonna use sine because, I haven't used it for a while, or that's the one I always use, and at least sometimes it works. No. We're gonna be better than that. And how do you pick? You look at what information you're given, and then you compare it to your possible trig ratios. So most of you have probably heard of SOHCAHTOA before. I'm going to fess up. I don't use it. I don't know why. Well, I do. Whoops. Because I learned this when I was in school, and it just works better for me. Our teachers just said memorize and be done with it. I really wish we had known about SOHCAHTOA. Would have been a whole lot less stress. So this is equivalent to this. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I tend to write them like that. If you do sine theta is like that, that's fine. That's all good. Anyway, let's get to the questions. So, number one, label your hypotenuse. Just actually, let me phrase that. Number one, label your triangle. So we got our hypotenuse here. So you can't see around my hand there. And we go down our hypotenuse here. There's my adjacent. And there's my opposite. So I have a number where there's an adjacent. And I had a number, although I wrote over it. Silly person. For my hypotenuse. So adjacent and hypotenuse. If I go here, that's opposite and hypotenuse. There's adjacent and hypotenuse. So this is cos theta is adjacent hypotenuse. And I always put theta there, even though there's a little question mark there. I'm just going to put theta because, I don't know, because you can put in whatever letter you want. But theta is just a nice general one, and adjacent over hypotenuse. All right, let's work down. Oh, I like this one. See this one? This one's cool. You've got one there and one there. If you watch the previous video, my trick is if you have like two sides, it's tangent every single time. So, but we'll do it anyway. Go across. There's my hypotenuse. Around the corner. That's adjacent. That's opposite. And those are the ones that I have numbers for. So adjacent and opposite make, oh, tangent. I said that a while ago, I forgot. Tan theta. Okay, there's the TOA part, opposite and adjacent. All right, our next one here. There's my hypotenuse. And I go around, and there's adjacent, and that's opposite. But I care, I have hypotenuse, I have adjacent, and adjacent and hypotenuse. Oopsies, better write it down here. Oh, adjacent and hypotenuse, there you go, it's cosine. Oh, look at that one. That's really weird. Look at that. We got numbers for everywhere. They're trying to mess with you. But you know what? Still label hypotenuse. And go around the corner. There's your adjacent. And get to the side and it's opposite. Well, pretty much you could use, I just realized you can use any of the trig functions because you have opposite and hypotenuse. You have the numbers for them. And that would be sine. Look that up, will not be sine. You have hypotenuse and adjacent. You could use the 95 and the 57, which would be cos. But you also have the two sides, so that would be tangent. Which then pretty much tells me that that's going to be the same answer over there, because if you see, all three numbers are there. Ta-da, didn't know that. Never thought of that until I worked out the question just now. All right. I should have said this a long time ago. Turn off the video. I went through half of it. Turn off the video, do the other half, and then turn it back on and go, yay, I know what I'm doing. Right? I'm going to trust that you did. Here we go. Hypotenuse. Around the corner is adjacent. Opposite. There's a number, and there's a number. Because eventually we're going to be doing something with those numbers. Eventually we're going to use our calculator and start figuring out, oh, what these angles are. But not right now. Not in this video. So adjacent hypotenuse, that is, oops, bring it down. That's cos. Sorry, my apologies. I got PMS, post-meal sleepies. Go ahead and use that. I learned that from one of my friends. Okay, sorry. Here we go. There's my hypotenuse. Go around my angle. It's opposite. Whoops. No. My bad. That's what happens when you do a whole bunch of videos all at the same time. Round the corner becomes adjacent. Because, you know, around and adjacent both start with A, so it's a memory tip. And this is opposite. Or you could just say, well, there's my angle, and if I go to the opposite side of the triangle, it's there too. Whichever works. So I have a hypotenuse where there's a number, and I have opposite where there's a number, and opposite, so it's going to either be sine or that or tan. And I have the hypotenuse. So ta-da, there we go. Excuse me. I'm going to try something. Check this out. Okay, what if you wrote SOHCAHTOA every time? It doesn't take that long. Oh, you could time me. I bet less than a second. I don't know, but I'm sure it's not going to waste too much of your time to write that every time. So what if we did this? Let me take a look. There's my hypotenuse. I'm just going to label it first. There's adjacent, and there's opposite. Okay, so I have the hypotenuse, and I'm going to take my highlighter, and I'm going to say, well, there's hypotenuse, and there's hypotenuse. It's got to be one of those two. I also have a number for opposite. So there's my opposite, and there's my opposite. But you can see with my handy dandy highlighting that this has to be sine because it's the only place where both letters are highlighted. And ta-da! Right, we said this one with all three numbers. Any one of sine, cosine, or tangent will work. Cool. End of the video. I'm hoping you're at the point of going, can we get on to something else? Because this is so easy.